All right, so we've discussed multiplication in general with whole numbers and different models for it. Now let's take a look and see how some of those models extend to use with fractions and really bring together our understanding of fractions that we've developed earlier, unit fraction, and this idea of multiplication. So if we have, remember that we had this statement, m times n equals p, or factor times factor equals product. And the first one is in America is generally used to mean number of groups, and the second factor is generally the number in each group, and the product means the total number. So if one serving of popcorn is 2 cups, then how many cups are in 3 servings? Well, if one serving is 2 cups, then if we need 3 of them, 3 servings, then we know we will have 3 groups of 2. Right? So we should be able to do figure out 6. That's the number of groups. That's the number in each group. And that's the total number. So, but if one serving is 2/3 cups, then how many cups are in 5 servings? Well, in this situation, we really need to go back to figure out what does it mean to have 2/3 of a cup. And remember, when we were talking about fractions very early on, we wrote this as 2 1/3. This was the size of the piece. And it was the size because we looked at it as the number you need to fill the hole. Right? So 3, you need 3 of them to fill the hole. And this was the number of pieces you have. So if we each third is this, so you need 3 of them to fill the hole, and you have 2 of them in a serving, then you can make sense, a child very early on can make sense what this means. Now, if you want 5 servings, don't you have 5 groups of 2 of these blocks? So wouldn't you have 5 groups of 2/3? So 5 groups of 2 1/3. Right? So if you have 2 1/3 or 2 of those squares and 5 groups of those, it makes sense that it would be 5 times 2 times 1/3. So 10 1/3 or 10/3. Right? So there isn't really a leap in interpretation if the student has a solid understanding of unit fraction and what it means to have a non-unit fraction like 2/3. So the 5, so in a way, in this situation, we're not only using the groups, the number of groups, and number in each group, right? We're also using this associative property here, where we're multiplying the 5 times 2 first of 1/3. All right, so let's take a look at a different word problem where the multiplication is 4 times 3/5. So we can rewrite it as 4 times 3 1/5. So number of groups, and then number in each group. Okay, so let's try to make a context for this. So each goodie bag uses 3/5 of a pouch of gummies. How many pouches of gummies do you need to buy to make 4 goodie bags? Right, so each goodie bag uses, apparently can't write today, uses 3/5 of a pouch of gummies. How many pouches do you need for 4 goodie bags? So let's take a look at the next one. If you have 3 servings of a sports drink and 1 serving is 4/5 of a liter, then how many liters do you have? Make a math drawing and write an annotated equation for this problem. Okay, so 3 servings of a sport drink, 3 servings, and each of the servings is 4/1/5. So let's try to make a math drawing. So 1 serving is 4/5. If each one of these is a fifth, then one drawing is 4/5. 1 serving is 4/5. And we need 3 of those. So we need this one, and then this one, and then there. Each of them has 4/5. All right, so 3 servings. So we have 3 groups of 4. So we should have 3 times 4 1/5, which is 12/1/5. And we could simplify that because we could find where the whole is. So there's 5/5. Right, that makes a whole. There's 5 more fifths, that makes a whole. And there's 2 more. So this is 2 wholes and 2 fifths. Okay. So, just by using the knowledge that the students already have of our units and just basic multiplication, there's not that much of a jump between for expanding or generalizing from whole number to fraction multiplication. Okay, so let's take a look at the next activity here. Extending multiplication to fractions, part 2. So if we look at some other examples, let's see whether we can find where that multiplication is starting to make sense. So if 1 serving of juice is 12 grams of sugar, then how many grams of sugar are a quarter of the serving? Complete the math drawing and write and annotate the equation of for the situation. So if we have 1 serving is 12 grams, and we're going to find the quarter, which means you need 4 of them to fill that serving, then how many grams are going to be in it? Well, if we have 12 grams in 1 serving, we could split it, right, into 3 sets of 3 grams. And you would need 4 of them to fill the whole, so this one would be 3. So a quarter serving would be 3 grams. So it's interesting that what we actually did was we actually took 12 and divided it by 4, right? And do you remember that that was the same as 12/4, which is 3. Or we also wrote it as 12/1/4. Okay. So 12 divided by 4, 12/4, or 12/1/4. And you notice that this 1/4 shows up right here. So it makes sense that those things would be connected. So you're taking a quarter of the serving of 12. Write a word problem, makes and explains a math drawing for 1/3 times 15. So I will leave that to you to look at the kind of problem, the structure of the problem number 1, and see if you can come up with a different context, but the same structure for number 2. Okay, so if 1 serving of cheese is 8/3 ounces, then how many ounces are in a quarter of a serving? Complete the math drawing and write and annotate an equation of this situation. So 1/4 is 8 ounces. 8/3 of 1 serving, is 8/3 of an ounce. So this whole rectangle is 8/3 of an ounce. So what is each one of those pieces? Don't we need a quarter of that? If the whole thing is 8 1/3, how much is going to be in each of those pieces? Well, if you need 4 of them to make 8 1/3, wouldn't they be 2 1/3? Right? Does that make sense? That if you take 2 1/3 4 times, you would fill the whole serving, 8 1/3. So that would be 2/3 ounces. So when we looked at 8/3 as 8 1/3 and divided it by 4, then what we had was 2 1/3. So we took 8/3 and multiplied it by a quarter or divided it by 4. We got 2/3. Very interesting. And notice we're not doing anything here that has any kind of procedural algorithmic feel to it. We're not saying multiplying across the top, multiply the bottom. We're not doing any of that. We're just making sense of what is going on in pictures. So let's look at number 4. If 1 serving of juice is 1/5 of a liter, then how many liters are in 1/3 of a serving? Okay, so it says that we want to turn the 1/5 into an equivalent fraction, perhaps, but let's make sense of it first. This is 1/5 of a liter, right? If you need 5 of these to make 1 liter, to make 1 liter. Okay. And what if you take 1/3 of that? You need 5 of these big pink ones. Well, how many are you going to need of the blue ones? Well, you need 3 blue ones to make a pink, and you need 5 pinks to make a liter. So wouldn't it make sense that you need 3 times 5 of these to make 1 liter? So this would be 1/15. Wouldn't that make sense? Wouldn't it also make sense that we're taking 1/3 of a 1/5? And we're saying that that's 1/15. That's very interesting. And before we start, we're very tempted here to make a rule, but before we start making a rule, the children need to be able to see many of these examples and come up with their explanations. Now, if we wanted to look at this as the way they looked at it, as turn 1/5 and into equivalent fraction, well, we could have taken that and made it into an equivalent fraction by, let's say, well, 5ths are not very convenient, but if we take 15ths, that would be helpful because we can take 1/3 of 15. Right? So then the little guys are going to be 1/15th, right? And in 1/5 of a liter, there are 3/15ths. If you take 1/3 of that, you get 1/15th. Okay. And again, I'll leave you with number 5 to make a problem similar to number 4, but in a slightly different context. So let's look at number 7. So if 1 serving of frozen Slurpee is 4/5 of a liter, then how many liters are in 2/3 of the serving? All right, so if we look at this picture, and 1 serving is 4/5, and the picture, if we just cover up the bottom, the picture here doesn't show 4 or 5, so we don't know whether any of these are 5ths or any of these. It really doesn't make sense for a student who is looking at making the number 4/5 make sense. So instead, if we look at this as 4 1/5, then whatever this distance is, whatever this overall distance is, really it should be split into 4 pieces. So there's 1, 2, 3. So into the 4 pieces. Right, like this. Okay, so then this is 1/5 and 1/5 and 1/5 and 1/5. Okay, now these lines here and here, these lines, let me use a different color. These lines don't actually make sense when we're trying to figure out what 4/5 of a liter is. So they're actually quite confusing for a student. Instead, what we say, oh, right, well, those are our 4/5, and we want to figure out how we can look at 1/3 of that. Well, if we're talking about fifths, looking at a third of anything in fifths is not really helpful. So maybe, just maybe, we can cut this piece into even smaller. So maybe if we look at thirds, and look at that, that lands right on one of those lines that we couldn't make sense of. If we look at third of that fifth, then we're actually looking at 15ths. Because when we had fifths that we were looking at, we needed four of them, for one serving, and 5 of them for the whole. But if we're looking at 15ths now, and each one of these little pieces is a 15th, then we'll need 3 times as many of them, right? So we need 12 of them for one serving. Okay, now we'll say, all right, well, if 12 15ths is one serving, then how many is a third of a serving? So how many if 12 15ths is one serving, how many 15ths are in a third of a serving? So in a third of a serving, we have 4 15ths. And another 4 15ths in another third of a serving. So two thirds of a serving are 8 15ths. Do you see how a different kind of picture could mess up a student's way of thinking? Right? So splitting 4/5 into thirds is actually going to cause a cognitive challenge for students. But splitting them into, representing 4/5 first, and then preparing that situation by splitting it into 15ths, that's where it sets the student up to solve the problem. It sets the student up with a visualization that'll help them solve the problem. What we actually did was we took 4/5 and we multiplied that by 2/3. We took a third of 4/5, right? And then to figure out that it was 4 15ths. And then we multiplied that by 2, right? Okay. So the answer for that would be 8 15ths, or was 8 15ths. And you can do the same thing with number 8 by creating another problem, a similar problem to number 7, but now with 4/5 times 2/3. So we're really looking at commutative property of multiplication with fractions.